Hello, welcome to India's most comprehensive e-learning platform, BYJU'S Exam Prep, and also special welcome to this great series that is IIT Kanpur previous year questions. Hope you have really enjoyed the previous section. Of course, we are going to discuss more and more topics in this lecture. First of all, good evening to everyone who is present in the chat box. Let's wait for 1 or 2 minutes so that all the students will join together so that the session will be too much interactive. In the previous lecture, that means yesterday lecture, we had a great interaction on block diagram reduction. Followed to that, we have also discussed about the stability concepts in detail. Hope you really enjoyed the shortcuts also, and I have understood from the comments in the comment box, and let us continue the same harmony even in this lecture also. As you all can see on the slide, we are going to mainly focus on time response as well as frequency response. Not only these two, we will also see the frequency response plots also. So today the session may extend little bit more, so you must have patience till the end. Well, before going to the actual session, let me quickly introduce myself to the students who are very new to the platform. Myself, Phanindra. All put together, I had an experience of 11 plus years in teaching industry for GATE as well as ECE Aspirant, and as you can see on the chart here, all put together I have guided more than 50,000 students in the subjects of control systems, measurements and industrial instrumentation, and I am specially known for industrial instrumentation. Well, Mohammed Mujzid Ansari, good evening. Madhuri, good evening. Hema, good evening. Jeevan Malik, good evening. First time I am seeing the word Jeevan Malik. Anyway, good evening. Abdullah also good evening. So let me quickly go to the topic here. As you all can see, we need to cover all these chapters, especially for IIT Kanpur series, correct? So we have already discussed about these basic concepts and stability. Who else and whoever missed the concepts in the yesterday's class, please go back to the previous session and attend. In fact, to go through all the lectures, in fact all the topics, so that you will really enjoy a lot. And in today's lecture, we will going to cover all these topics little bit fast. As I was saying, yesterday basic session, so I moved little bit slow, but today we will going to be very fast. Are you guys ready? If you are ready, so please keep in the comment box, yes, you are ready, right? So let's go to the time response analysis, which is really very important topic. Trust me, you will be having at least one question, and of course if you are lucky enough, it may be 2 marks, and if you are not so lucky, it may be for 1 mark, but definitely one question will be there, correct? Right. So let's go to the first question of the day from the time response analysis. All of you, please see this question. Take your pen and paper and put it everything together and make it very fast. I want the answer from your side very fast. This question was asked in ECE 2015 paper. Of course, it is from set 2 and 1 mark question. So please look at the statement of the question. A unity feedback system has a open loop transfer function g of s is equal to k divided by s into s plus 10. The gain k for which the system has the damping ratio of 0.25 dash. Clear? Any answer from your side, guys? So make it fast. I want the answer and the response both very fast. So you can see for the very first thing which was given here is, of course, h of s is equal to 1. But as per the introduction of the question and the statement of the question, one can write that g of s is equal to what? So it is going to be k into s divided by s plus 10, isn't it? So therefore, easily we can say g of s by 1 plus g of s into h of s, which is considered as a transfer function of the closed loop system, correct? So how can I say this one? So obviously this is, if you make it g of s and h of s if you use, and if you write it very fast, so what is the value you are going to get? I think Madhuri is too fast and too quick, very easily she has answered. Fine, I appreciate. So let me make it clearly. So it will going to become s square plus 10s plus k. So very simple, just use g of s and h of s here, then you will going to get the function like this. And if you compare this with the standard second order transfer function, what would be the standard second order transfer function? Omega n square divided by s square plus 2 zeta omega n into s plus omega n square, isn't it? So therefore, look at the beauty of this. When you compare this to both sides, what it is there? Omega n square is equal to k, of course, and omega n is equal to under root of k. Simple, right? So because you can compare this with this, and then you can compare this side and this side here. So what will be there here? So 2 zeta omega n, all the way I can write down this as a 10. Easy, right? So then what is a zeta? Zeta is going to be given as 0.25. 0.25 means 1 by 4, right? So 2 into 1 by 4 into zeta, sorry, into omega n here. So give me 1 minute time. Let me finish it fast. I hope many of you have completed this. Very good, right? Omega n is equal to 10. So how much it will be equal to here? So 2 times, right? So of course omega n is equal to 20 here. But as you already know, here of course Kumar, Kokila, many students have answered. Great. Isha Agarwal, yes, good evening, right? Omega n is equal to 20. But as you have seen, omega n is equal to under root of k. So therefore I can say 20 is equal to root k, and k would be equal to how much? Square on both sides. And when you squaring on both sides, it will become like 20 square, which is equal to 400. I hope many of the students, they have solved. Even compared to me, they are very fast. I really appreciate. Fine. So what would be the correct answer? Correct answer is 400, and I really appreciate the students who have done it, right? Let's quickly go to the second question. Statement of the second question. Babu Bangaram, good evening, right? Let's go to the next question. This was the question asked for 1 mark in the year of 2001, and this is also very simple question. So fast. Just take 10 seconds and make it fast. Okay. I really appreciate those people who make it very fast, because these are very simple questions. If the characteristic equation of a closed loop system, see, directly they have given closed loop system, fine, is this much, one second, s square plus 2s plus 2 is equal to 0, then the system is dash, right? So we all know that the closed loop system transfer function, in fact for second order system, it must be equal to what? Omega n square divided by s square plus 2 zeta omega n into s plus omega n square, correct? So now this is considered as a characteristic equation in general, isn't it? Right? So therefore I can say s square plus 2 zeta omega n into s plus omega n square, all the way this must be equal to what? The characteristic equation was given there, right? So let us take, oh, very fast, very good guys, right? So s square plus 2s plus 2 here, correct? So omega n square would be written as equal to 2, because you can compare these two here. So it would be equal to 2. Therefore omega n is equal to under root of 2. This is one thing, correct? And then compare this side. 2 zeta omega n is equal to 2. Then I can say 2 zeta omega n is equal to 2. Of course zeta is equal to what? 2 divided by 2 times of omega n. So of course 2 get cancelled here. So what will be there here now? 1 by omega n. What was of omega n? Already we have seen that omega n is equal to root 2. 1 by root 2, technically it is going to be equal to 0.7. So what does it mean? Zeta value is equal to 0.7. So it means that it is going to be less than 1. If it is less than 1, if the value of zeta is less than 1, what is this called as? This is called as underdamped system. Clear? Very good. So many students have already answered. Nagarjun Reddy have kept answer as C. So underdamped system is the correct answer. Option C is the correct answer for this question. So let's get into the next question straight away here. So this question was asked in the year of 2015 for 1 mark. Fatafat, all of you, right? Make it a system with a transfer function g of s is equal to 1 by s square plus 1 has 0 initial condition. The percentage of overshoot in its step response. Please see this one. This is very important. Many students, they will going to keep answer very fast, but without knowing the idea here. So you must know this as a step response first of all. Okay. So what is this system here? So they have mentioned clearly like g of s is equal to 1 by s square plus 1. Now if you compare this with the standard second order transfer function, let us say omega n square plus s square plus 2 zeta omega n into s plus omega n square. Now may I know what is the zeta value and omega n here? Omega n is equal to 1 straight away when you compare the numerator, right? And when we compare the others here, so this is, there is no coefficient of s in the denominator, but here there is a coefficient of s. So what should we do here? So obviously 2 zeta omega n must be equal to 0 here. Undoubtedly zeta will be equal to 0, correct? So if zeta is equal to 0, anyone fast, what happened guys, right? You must make it very fast. Zeta is equal to 0. Zeta is equal to 0 means it is going to be undamped system, isn't it? So look at the beauty of this. This is considered as an undamped system. Well, if it is undamped, what does it mean? You will be having continuous oscillations, correct? If we are having a continuous oscillation around the set point, that means if you look at, so all the way, like let's make it like this. Okay, so just give me 1 second time. I was expecting the answer from your side fast, right? So here if you take this as a time, of course if you take the required set point is going to be 1 unit here, then you must understand that the value of the response will go up to maximum 2 and then it come and dance like this, right? In fact, you will be having the maximum value as 2 here. Clear? So the peak overshoot, if you see 100%, isn't it? You required 1, but you got 2. Means, what does it mean? It became twice, means 100% rise, right? So we don't understand this. Fine, no problem. You can even follow the formula also directly, because percentage of peak overshoot, probably everyone who is preparing for the GATE examination, they might be knowing this one, right? Naveen Kumar, hi, right? So what is the formula here? E power minus zeta omega n zeta by under root of 1 second. Yes, so there are two ways. You can directly use the percentage of peak overshoot formula, right? So what would be the formula? E power minus zeta by, in fact, you will be having so much of function here, correct? You will be having some function here, because I feel that every one of you are aware of this one, because you need to type that also. That is my intention, right? So there is a big formula into 100 is there, right? So you can simply see that when zeta is there and multiplied by so much of factor here, as the zeta value is 0, straight away I can say 1 into 100. So obviously this is going to be equal to 100%, correct? So the answer to this question is straight away it is going to be 100%, but you need not to do. If you are clever enough, by looking at the statement of the question, as you feel that this is going to be undamped system, naturally in the step input when you apply, the response will continuously oscillate, and it will oscillate in such a way that the peak value will be more than 100% of the actual final value that is to be reached, or else the set point what we applied. Clear? Easy questions, right? So that's what I am saying, that the questions which were asked in, especially in IIT Kanpur, there are few questions which are very, very tricky and which are very good, but most of the questions are like this, and especially in this chapter the question standard is less. I too agree with this. Now go to the next one. right, yes, but I'm sorry, what I mean to say is you no need to use the formula also, because you know that in the formula e power minus zeta is there and there is some other thing is there, but when zeta is 0, obviously e power 0 equal to 1. 1 into 100, that will become 100, right? So likewise you need to think fast actually, right? So this question is good question, I feel. Not good question technically, but it will take some time as you need to go for completely, right? So look at the statement of the question, right? The output of a standard second order system for a unit step input is given as 1 minus 2 divided by root 3 into e power minus t cos root 3t minus pi by 6. The transfer function of the system is dash. Okay, so I feel that this is not a difficult question, but this will take some time. Any one of you, can you make it fast here, guys? So make it fast. So what we should do here, 1 minus, first of all, what is cos A minus B? So look at that, this is going to be considered as cos A, and let me consider this as a cos B here. Clear? So y of t technically we can write down like this, right? 1 minus, look at this, 2 divided by root 3, of course, e power minus t. Let me take clearly here cos A minus B. So therefore it could be written as cos of root 3 into t, right? Cos A into cos B. Cos B is how much? Cos of pi by 6 here. Very good. And cos A minus B. What is that? Cos A cos B plus sin A sin B. Correct? So therefore I should write down this as sin of root 3t into sin of pi by 6. So please consider this sin of pi by 6. Of course, this is a little bit horrible to see this one, but sin of pi by 6. I have limited space, right? So moving ahead, the same y of t now can be rewritten as 1 minus 2 by root 3 into e power minus t. What is this? Cos of pi by 6. Cos the t. How much it is? It is going to be root 3 by 2. Of course, we still have like cos of root 3 into t here. Correct? This is also correct. Anyone, can you get the answer here now fast, guys? So plus sin of pi by 6, what is that? That is going to be 1 by 2, easy. And along with that we have like sin root 3 into t here, correct? So this is what we are having. Now when you multiply inside, then what you will going to get as a y of t here? Y of t is equal to 1 minus. So root 3 will get cancelled when you multiply inside, and 2 will get cancelled here, right? So what will be there here? So it will be something like e power minus t into cos of root 3 into t, correct? That is the first part. Plus when you multiply this inside, this 2 will get cancelled and you will be having like 1 by root 3 into e power minus t into sin of root 3 into t. So this is taking some time, right? So Nobody has given the answer, so I am expecting the answer from you. Fine. Anyway, if you go ahead, what it will be if I go for a Laplace transform of this? If I apply Laplace transform for this, then it will become y of s here. Of course, what is this going to be? This is going to be 1 by s, because it is a unit step input u of t. 1 into u of t will be there. So when I apply Laplace transform for 1, then you will going to get 1 by s here, right? Minus, what about the Laplace transform for this one? Correct? E power minus t into cos of root 3 by t. So it is like e power minus at into cos of cos omega t. So it will be like s plus 1, because e power minus 1 is there. So plus s plus 1 whole square plus root 3 whole square. That is exactly what you are supposed to get here. Easy, right? And then else what you will going to get here? So plus any additional things you will going to get, yes, plus again e power 1 by root 3 is there here. I appreciate, right? And e power minus t into sine omega t, so that is omega. So root 3 divided by what will be there here? So this is going to be s plus 1 whole square plus root 3 whole square here. Correct? Of course, root 3 will be out. No one has given the answer up to now, right? That's why I told you that this is not a difficult question, but of course it takes some time. I too agree with you, right? So therefore, y of x can be written as 1 by s minus, what else is there? 1 by s minus s plus 1 right, divided by s square plus, what is this? S square plus 2s plus 4, isn't it? S square plus 2s plus 4, that is what you will going to get. And even if you see otherwise, this one also, what is this one here? So plus 1 divided by s square plus 2s plus 4. So simple, isn't it? Right? It's not difficult question. First of all, it takes some time. That's it. Right? Moving ahead, what you will going to get as a y of s here now. Right? So just use this one clearly here. So it will be like s into s square plus 2s plus 4 here. Right? So most important thing is this will going to be s square plus 2s plus 4 minus s square minus s. Of course, this is going to be minus s here. So obviously what you will going to get, this will be out here, this will be out here. So ultimately you will be having like y of s is equal to 4 divided by s into s square plus 2s plus 4. Correct? So now most important thing is this can be written as 1 into 4. And this 1 by s, what is this 1 by s? Right, option D, very good, Rams King, excellent, right? So 1 by s is going to be considered as u of s, correct? That is in fact the input, right? Into 4 divided by s square plus 2s plus 4. Now you can take this u of s to left side, right? So then it will going to become like y of s divided by u of s, which is considered as a transfer function, and u of s is actually nothing but the unit step input here. Clear? So u of s by y of s by u of s, all the way now it can be written as s square plus 2s plus 4. Clear? What would be the answer here? Option D is the correct answer here. D for Delhi. Now tell me guys, do you think that this question is difficult? I'm sorry, Naveen, Nagarjun Reddy, Jeevan, please tell me, do you think that this question is difficult? No, this question is absolutely not difficult, but it is taking time. But you must understand this was asked for 2 marks. And if you are so confident that you can answer this, then continue to do till the end. It may take 2-3 minutes, but you will going to get an accurate answer and you will get 2 out of 2, right? So yes, that's what I am saying. It is not a difficult question, first of all, right? But it takes time, right? So now let's go to this wonderful question. This was 2007. See, I have seen some of very good questions on the dominant pole concept. So that's why I have included these questions by neglecting so many other questions also, right? So the question was this: the transfer function of a plant T of s is equal to 5 divided by s plus 5 into s square plus s plus 1, right? The second order approximation of T of s using dominant pole concept is dash. Clear? Anyone first? So when you look at this, what are the poles here? So the first pole is going to be minus 5, because s plus 5, if you equate it to 0, you will going to get minus 5. And then look at that, s square plus s plus 1, right? So if you take that, you will going to get complex conjugate pole, right? S2 and S3 are going to be complex conjugate poles, right? Can you tell me what are the poles here? S square plus, now you can do simply like, 1 second, yes. So simply you can take the denominator and make it equal to 0 here. So what is this? S square plus s plus 1 is equal to 0. right? So what are the poles we will going to get? Let me call this as S2 and S3 here, which is equal to -1, of course, plus minus b plus or minus under root of b square minus 4ac, right? So minus 4 divided by 2a. So what are these two poles here? S2 and S3. That means the remaining poles are going to be -1 by 2 plus or minus, of course, it is under j into root 3 by 2 here, correct? So now you tell me what would be the correct answer, right? So if you can explain it very great, yes, I am explaining, don't worry. So just see here. Now there are 3 poles on the j omega place, right? So let us look at this way, right? So all of you please see here. So when you take S plane here, we all know that this is a sigma. Of course, this is minus sigma here, right? And this is j omega and this is minus j omega. Look at that. The pole, one pole is at -5, right? So which is very far away from the j omega axis, correct? Where are the other poles here? -1 by 2. This is going to be -1 by 2 plus j into root 3 by 2. One location. This is one location. And there is another location here which is near to the j omega axis. -1 by 2 minus j into root 3 by 2 here. Clear? So in fact, let me take a few seconds of time to explain this, because this is very important concept. As somebody is asking that, let me take few minutes of the time here, right? So what is there here? Now you must understand this is going to be minus sigma, and as I was saying, -5 is somewhere here, correct? So dominant pole concept, whenever this concept comes, you must understand whatever the poles that are away from the j omega axis, neglect that. That means neglect, that means don't consider this. Clear? So that is because generally the pole which is away from the j omega axis will not contribute too much in the time response. Suppose you have 1 by s plus 5 here and 1 by s plus 100. Now tell me, what is the inverse of this one? Inverse of this one will be e power minus 5t. Inverse of this one is going to be e power minus 100 into t. Correct? Now, if you substitute t is equal to just 1 second, if you substitute t is equal to 1 second, it will going to become like e power minus 5, whereas it will become like e power minus 100. Correct? E power minus 100 means it is almost equal to, it is very, very less value. Correct? So that means if the pole is far away from the j omega axis, in its time response, even for a very small time, its value will be very negligible. Clear? That is the reason why the poles which are away from the j omega axis, will consider them, they are not there, right? So we'll just neglect them. When you neglect that, what will be the transfer function now, right? So is this concept is clear? All of you please keep it in the comment box. Is it clear or not? That means I am saying that just simply neglect this one. So when you neglect this one, you will be having like 5 divided by s square plus s plus 1. Is it clear or not? Everybody should answer here. Yes, it's very clear now. Thank you very much, right? 5 by s square plus, what is this? Yes, s square plus s plus 1. Now students solve up to here, right? And they select the answer as, option C, because option C is available. So they will go for option C, but it is not correct. It is not correct, right? Why it is not correct? Because most of the students, they do mistake like this. Because you must understand that when you are removing the pole, you should not violate the DC gain here. Now can you see here, what is the DC gain here? Can you see here? Look at that, what is the DC gain here? So from this DC gain, calculate DC gain. Just DC gain means we should substitute omega tends equal to 0. Clear? So usually you have to take the magnitude and substitute omega is equal to 0. In a simplest language, if you substitute omega is equal to 0, then this will be out here, this will be out, this will be out. So 5 divided by 5, you will be having that as a 1 here. So that means the original transfer function is having DC gain is equal to 1 in an easy way, because I told you that omega should be 0 in magnitude function. In simple way, we can say keep wherever s is equal to 0, s is there, you can keep 0 to get the answer here, right? So that means the DC gain is 1. But now the reduced form has a DC gain of how much? 5 divided by s square plus s plus 1. No, this is not correct, right? Again, the reduced form should also have the DC gain equal to 1. Means you must have 1 divided by s square plus s plus 1. Clear? So now you look at the DC gain. Just substitute omega is equal to 0 in this, right? If you substitute omega is equal to 0 in the magnitude function, then it will become like 1 divided by 0 plus 1, obviously this is equal to 1. So that means this is going to be the correct answer, as it is providing the DC gain is equal to 1, which is equal to the DC gain of the original transfer function. Clear? Sir, where are you from? Harsh. Right? So anyway, option D is the correct answer here. That is, I am from BYJU'S Exam Prep. Of course, 1 divided by S square plus S plus 1. Clear? And this was for 2 marks. Most of the time students go for the C, but that is wrong answer. And now onwards you must actually get a clear idea, right? So every time whenever you are working on this, be clear that DC gain of the reduced form and the original form both must be same. That is a clear idea. Clear? Right? So G1, you are right. So B might be having the DC gain as 1, but look at the poles of this, right? These poles are far away from these poles, from the j omega axis. Clear? Here the poles are near to the j omega axis, but here the poles are away from the j omega axis. That's why we don't consider this. Is it clear, G1? Please answer here. Yes, of course. Let me go to the next statement. My favorite topic, that is root locus. Guys, root locus is my interested topic, and those students who have seen the recorded section of my classes, and also those students who have attended the live sessions, you might be knowing that I completely teach the root locus in the different way, and if anybody has the doubts, you can ask me, right? So now let's go to the first question in the root locus. See, for the system shown in the figure, S is equal to minus 2.75 lies on the root locus if K is dash, if K is equal to dash. Now it is 2015 question, and if you follow formula, you will going to get wrong answer here. 2015 ECE set 3 for 2 marks. See, they have given 2 marks means they are not mad, right? So there is a logic behind this, right? Many students, they generally use the formula and get wrong answer. Now I feel that my students are, you know, they are genius, so try to answer this very easily. Okay, so first of all, whenever you get this, get the characteristic equation, which is equal to 1 plus g of s into h of s is equal to 0. Correct? So what is this one? 1 plus, first of all, k into this total into h, right? So this is k into s plus 3 divided by s plus 2, all put together. This is considered now as g of s. Correct? And h of s is equal to 10 here. So let me write down here, fatafat here, g of s into h of s. So what would be this one? K into s plus 3 divided by s plus 2 here. Of course 10 should be multiplied here, so let me write down 10 here. Clear? So now this must be equal to 0. Clear? This must be equal to 0 here, right? Any one of you fast, right? So now from here it is very easy to write that 10 into k into s plus 3, right? So that is equal to minus of s plus 2 here. So easy again, minus of s plus 2, and then you can say k is equal to minus of s plus 2 divided by 10 into s plus 3. Correct? So what do you mean by root locus? Root locus means it is a locus followed by the roots of the characteristic equation or poles of the closed loop transfer function. Correct? Now this is the characteristic equation we have solved, and all the way when we solve we got k like this, and he is saying that this is going to be the root of the closed loop control system. Correct? So root of the characteristic equation. Correct? So if it is the root, then in root locus k will be varying, because we will be taking forward root locus, and k will be varying from 0 to infinite. Correct? So that means if this point is there in the root locus, means if I substitute this s value here, then k value should come positive. Madhuri, wrong answer. So wrong answer, Madhuri, please check it. So if you substitute this point here, then k should come positive. Then only I can say that this value is actually, or this point is there on the root locus. Correct? So what would be the answer? So minus, so you can see minus 2.75 plus 2 here. Correct? Of course this is going to be 10 here, and s plus 3. What is s plus 3 here? Minus 2.75 plus 3 here, as I was saying here. So what would be the final answer here? So minus, anyway it is there, and this is going to be how much? Minus 2.75 plus 2. So this is going to be minus 0.75 here divided by 10 into minus 2.75 plus 3. So this is going to be 0.25 here. Correct? So what would be the answer here? Of course this is going to be 3 divided by 10. Undoubtedly this is going to be 0.3 here. Clear? 0.3 is the correct answer. None of you got correct answer here. So because you have done mistake, maybe you might use some formula here. So 0.3 is the correct answer. As we are getting k value greater than 0, 0.3 is greater than 0. So I can say conveniently that this point is there on the root locus. If you get k value less than 0, when you substitute any point, it means that that point is not there on the root locus, in the root locus plot. Clear? Yes, Hema, correct? You are correct. So 0.3 is the correct answer. Now, is it good question? I mean to say it's not a good question, but it is on very fundamentals where students commit the mistake, and that is what reflected even in the chat box also, right? So, but anyway, guys, I hope you got this point, right? So let's move on to the next question here quickly, because we have very limited time. So this is 2015 question for 1 mark. Fast, every one of you. Interesting, right? These questions are really interesting. A unity negative feedback system has a open loop transfer function. G of s is equal to, of course, this much. The value of the gain k greater than 0. See, this is a gate question, and they have clearly mentioned k should be greater than 0. That's what I told you, that any point which is there on the root locus plot, if you take that s value and substitute the s value in the characteristic equation, k should come greater than 0. That is a fundamental logic. Nobody can deny that, right? So now can you make it fatafat here? So what would be the idea now? Any one of you? At which the root locus crosses the imaginary axis. Again, whatever may be the question, whatever may be the style of the question, the very first thing what you require in control system, especially in root locus, is characteristic equation. Clear? So what is the characteristic equation now? 1 plus g of s into h of s. G of s, it's given like k divided by s into s plus 1. By this time you must get the answer here, right? S into s plus 1 into s plus 3. Very good, Madhuri. Okay, right? Into h of s is 1, that must be equal to 0, right? So therefore, what should I say here? S into s plus 1 into s plus 3 plus k equal to 0. Madhuri, why you have done the mistake in the previous question where it went wrong? Cross check that and let me know, so that I will also know that this is the way how to do the mistake. Madhuri, please let me know. This question your answer is correct. Absolutely, you are so fast. And in the previous question you have mentioned like 0.69. Just check where you have done the mistake. So Basha, this is not dk by dx here now. You require imaginary crossover point, right? Imaginary axis, right? So that means whenever root locus cuts the imaginary axis, either that should be like j omega or minus j omega, correct? So that means the root will become j omega. When the root locus cuts the j omega axis, then the root will become j omega, correct? Root will become, s value will become j omega. S value will become j omega. Anyway, what is this value here? So s square plus s, of course, as I said, into s plus 3 plus k is equal to 0. So tell me, what is this value now? That is going to be s cube plus 3s square plus s square, 4s square plus 3s, of course, plus k equal to 0. Now you must understand, this is a characteristic equation, and this characteristic equation should satisfy s is equal to j omega if the root locus cuts the j omega axis. Clear? Right. So let's move on to this first here. Right. So s square plus what I told you, 4s plus 3, 4s square plus 3s plus k equal to 0. And I am saying that s must be equal to j omega here, because if it cuts the j omega axis, so s should be equal to j omega. I think many students have answered this. So this is s cube actually, right? So j omega whole cube plus 4 into j omega whole square plus 3 into j omega plus k. I think 1 or 2 students, they have made extremely very fast. I appreciate those guys, right? Minus omega cube and 4 omega square, minus 4 omega square plus j into 3 omega plus k, that must be equal to 0, right? So if you go ahead, this is k and minus 4 omega square, so this would be like k minus 4 omega square, of course, and plus you can take j into omega outside. So what is there inside now, right? Inside you are going to have 3 minus omega square all the way, that should be equal to 0. Now it's very easy. Here we are having 0 plus j into 0, correct? J into 0. Now k minus 4 omega square, you must equate it to 0. Right side nothing is so I have taken it as 0 plus 0, and this must also be equal to 0. correct? So therefore what should I say here? So k minus 4 omega square, that would be equal to 0. So k must be equal to 4 times of omega square. Anyone who has a common sense, they can answer this, right? So what else is there other side? So other side we have like 3 minus omega square is equal to 0. So therefore omega square is equal to 3 here, correct? So when you see omega square is equal to 3, then obviously you can take this omega square value and substitute here. Then what it will become here? K is equal to 4 omega square. So therefore K is equal to 4 into omega square. Just now we got it, right? Okay, right, fine. So 4 into 3, that is equal to 12. So the answer is K is equal to 12. I repeat, the answer is K is equal to 12. Now I will be asking a very interesting question to all of you. Look at, focus here. Stop writing, stop answering, just focus here. All of you please focus here. So K is equal to 12, isn't it? Now the question is, can you catch correctly what is omega PC for this? Any one of you, what is omega PC? Means phase crossover frequency. Any one of you? I am really surprised to see the answer from your side, and I will be really glad to if I get the answer from your side. Omega PC. You may be wondering here, right? Sir, what is this, sir? When you are teaching root locus, why you are asking about phase crossover frequency, and this is about time response, that is about frequency response, how it is? See, in control system, everything is connected, and if you are clever enough, you can understand that all the concepts are correlated here. Clear? So, whatever the frequency where j omega axis, where the root locus is touching the j omega axis, that frequency itself, it is called as omega PC. If you don't believe that, right, how j omega common, sir? Right, Sai Charan, just give me 1 minute. First of all, let me complete this. Omega PC, I told you, correct? Omega PC is considered as a phase crossover frequency. You all know that, right? So whatever the frequency where you are touching the j omega axis, that frequency is called as omega PC. Here omega square is equal to 3. So therefore omega PC would be considered as root 3 here, because omega square is equal to 3 means omega is equal to root 3. That's all. Very good. Root 3 radian per second. And if you don't believe my words, you can consider this transfer function and go for the calculation of omega PC. If you know how to calculate, you will understand that as a root 3. Now coming to the Sai Charan doubt. Okay, Sai Charan, why we have made, because I understood your doubt that why we have taken S is equal to j omega. So I already told you. So this is your S plane, right? Correct? S plane. Now you know that this is sigma and this is minus sigma, and this is j omega and this is minus j omega, correct? Now you tell me, if I say there is if it cuts, root locus may go anyway, but if it touch like this, right? So that means if it is touching the j omega axis, means definitely it might be like j into 2 and it might be minus j into 2, or it might be minus j into 3 and it might be minus j into 3. As we don't know whether it is j into root 3 or j into root 2 or j into root 1, so we will be taking this as a j into omega. Clear? So we will take this as a generalized value of j omega, and now obviously this is equal to s here. Any value on the s plane is a s value only. So when I take this as a j omega, I will consider as s is equal to j omega in characteristic equation. Clear? So that's the whole point. Sai Charan, tell me, are you clear with this? Because I have explained this doubt only for you. Please answer in the comment box, is it clear or not? Now let's move on to the next question. No problem, Madhuri, it's okay. Please, let's see the next question here. 2015 2 marks question, and I feel that this is a wonderful question. Guys, you should not miss this question. Okay, at any cost you should not miss this question. Sai Charan, please let me know whether you understood this or not. Rest of the students, please make it this question. The open loop transfer function of a plant in a unity feedback configuration is given like g of s is equal to k into s plus 4 divided by, yes, very good, Sai, right, k into s plus 4 divided by s plus 8 into s square minus 9. The value of the gain k, for which minus 1 plus j root 2 lie on the root locus is dash. So indirectly they are asking what is the value of k, correct? They are asking what is the value of k. If you refer, the very first question what you solved in root locus is a similar kind of question, correct? But here we cannot construct the characteristic equation and substitute the complex pole in the characteristic equation to find out the k value. It's very difficult. So in that case, what we do, in short is, let us take what are the poles here. So can you see poles? Poles means we will equate the denominator equal to 0. So first is S1 is equal to minus 8. This is one pole, correct? And then equate this S square minus 9 is equal to 0. When you take S square minus 9 is equal to 0, then it will become S square is equal to 9 here. And when S square is equal to 9, can you tell me here what will going to happen? Anyone? What are the poles of this one? Fast, very fast. So make it fast, right? So S square is equal to 9 means then you will be having second pole as S square is equal to 9 means plus or minus 3, right? So one pole will be plus 3 and another pole will be equal to minus 3. Clear? So we are having first pole here, second pole here and third pole here. Clear? And now look at what are the zeros here. So look at what are the zeros here. So zeros, we have only one zero, that is if you make S plus 4 is equal to 0, as I was saying, you will be having like S is equal to minus 4, right? And this is a very good question, as I was saying. Let me see how many of you will be able to answer this fast, right? So first of all, when you are asked this question, you have to plot as like this one, right? S plane. Take S plane here. So this is j omega and this is going to be minus j omega, right? So this is not looking good. So let me take 1 minute here. Yes. Right. So first of all, where is the 0 here? So 0 is at minus 4. So that is one important thing. First let me take 0 here. 0 is at minus 4 here. Okay, fine. No problem. What are the poles here? One pole is at minus 8 here. So let us take this as pole minus 8 here. So this is pole, right? Minus 8. And what are the other poles here? Have you seen? Plus 3 and minus 3, right? So therefore, minus 3 I could take here. Of course, plus 3 I should take here. Correct? Plus 3 I should take here. Any one of you, have you got the answer for this? Because this is a wonderful question actually, right? So minus 1 plus j2, you require to evaluate the gain at that point. So what we should do? First of all, minus 1 plus j2 means obviously this would be somewhere here. So let us say this is minus 1 plus j2 point here. So if it is minus 1 plus j2, can you tell me how do we write this one? So look at that, right? So if you see the length from here to here, so I can say the height all the way, because this is going to be the point, I should say j2 actually. So therefore this will have a magnitude of 2 units, right? From this to this vertical ordinate is 2. Obviously from here to here this might be minus 1 here. Clear? So that means the distance is 1 unit, but the point coordinate is minus 1. No wrong answer. Madhuri, wrong answer. Please make it correct, right? Minus 1 here. Correct? Now relax and think. What would be the first thing you need to do here? You need to find out the length from pole and zeros. I repeat, find out the distance from each pole and each zero. Means you need to find out the length from each pole and each zero. So this is probably the first pole. Let us take this is the pole here, right? So what is the distance here? Can you find out what is the distance here? Now it is minus 1 and this is 3. Minus 3 means from here to here. If I say this is the origin here, can you tell me? 25.53. Excellent, Rajesh. Excellent. Very brilliant. Very fast. Very quick, right? So 0 to minus 1, 1 unit, and 0 to minus 3, 3 units. Then from here to here, what is the length here? Length is going to be 2 units, right? So that means from here to here it is going to be 2 units, and from here to here it is going to be 2 units, right? So is it looking like a right angle triangle? Now what would be its value here now? So look at that. This value is going to be opposite side, opposite square, that is opposite side square plus adjacent side square, Pythagoras theorem. So 2 square plus 2 square, that is equal to 4 plus 4. Obviously it is going to be 8. Under root of 8 is the distance here. Clear? Root 8. Very good. Sorry for the late, sir. Okay, Ravi, no problem. Next time you try to make it on time, right? So this is going to be root 8. Now let us look at the other side. Now this is a very interesting game actually. So please see here, all of you. Many students, they will be possibly doing the mistake here. So from here to here, what is the distance now? Now from when you are selecting this as the Pythagoras theorem, right? So now this is going to be the, like this table, correct? So here anyway this is root 2. But from here to here, what is the distance? Minus 1 to minus 4 means 1 to 4. Effectively the distance is 3. correct? Then again if you apply the Pythagoras theorem, under root of, so 2 square, that is 4, plus 3 square, that is 9. So 2 square plus 3 square, that is going to be root 13. Clear? Root 13 is going to be very good, Sachin. Excellent, right? Root 13. What about the next one now, right? Next one is going to be, right? So this is from minus 8 up to here, correct? So again the same thing. From here to here, what should I say? Minus 1 to minus 8 means it is going to be 7 units distance, correct? This is 7 units distance and this is 2 units. So then again if you apply Pythagoras theorem here, so that means this is the triangle now, right? So 2 square means opposite square, that is 2 square 4 plus 7 square, what is that, right? 4 plus 49, 7 square is 49 plus 4, so altogether this is going to be 53 here. Clear? This is going to be 53. So length is clear. Now from this again, because there is a pole here also, right? So now draw a line from here to here, no problem. Now you must understand clearly that there is a triangle even this side also, correct? So this is also a triangle here, correct? So from here to here, what is the distance? Fatapat, all of you. Here, oh, very good, Dipin, correct, root 53, good. Minus 1 to 3, this is going to be 4 units here. Minus 1 to 3 means here 1 unit and here 3, altogether 4, and anyway this is going to be 2. Then what is this value now? Under root of opposite square, 2 square, that is 4, divided by 4 square, right, 16. How much that is going to be? So 4 plus 16, obviously this is going to be 20. Clear? 4 plus 16, that is equal to 20. Good. So we got the lengths now, right? Now what we should do here is look at the last step of this. The gain K can be calculated like this, because ultimately we require to calculate the gain here. So we are evaluating the gain K here. How do we do that K now? Now K is equal to multiply the lengths from all poles, LP1 into LP2 into LP3, because there are 3 lengths from the poles, right, divided by zeros. Clear? Only 1 0 is there, so I am writing like L01, right? LZ1 means length from 0 1, first 0. Clear? So this is length from first pole. Clear? Length from first pole. You can take 3 as the first pole, no problem, right? So what is that? Root 20 here. So fine, this is going to be root 20. And length from the second pole. The second pole is, where is this? Minus 3. What is the length here? Under root of 8 here. So let me write down, this is 8 here. And LP3, that means the length from the third pole. What is the length from third pole? Under root of 53 here, right? So let me write down under root of 53. What happened, Rohit? Today you are so late, I guess. Rohit is missing, I think, right? Fine. Now when you make it this, last one is in the denominator, length from 0 1. You have only 1 0, that is here at minus 4, and root 13 is going to be the length from that point to the 0 here. So what should I say here? Root 13 here. So obviously if you make it the final calculation, K will be equal to, look at this, under root of 20 into 8 into 53 divided by 13. Any one of you, can you calculate fatafat and tell me what is the value of K here? Right, already somebody has given here. Yes, so take your calculator fast and tell me what is the value of this K here. Right, so it will come around somewhere around 25.53, something like that. Clear? 25.53. Now tell me, is this is really a good question or not? Again I must say this is not a good question, but it takes time, and accuracy is very important. See how fast I have done. Many of you are doing it at equal speed with me, but this is really a challenging question in terms of accuracy, correct? So of course it takes some time because it deserves that, right? So, and this is the only way you can solve this in the faster way. Okay, K is equal to 25.53. Good, very good. So tell me, have you enjoyed this question or not? Yes or no? Now let me go to the next question here. Next question, this was asked in the electrical paper, 2015 for 2 marks. Of course it is the set 2. Start reading the question. Very good. So how to calculate without calculator? You cannot calculate without calculator. That's why in GATE exam they provide the virtual calculator to you, right? And it is highly impossible to solve GATE paper without calculator. Clear? Right? So that's why, right? Now Jansi, very good. So please let me know. So this question, an open loop transfer function g of s of the system is given like g of s is equal to k divided by s into s plus 1 into s plus 2, right? For a unity feedback system, the breakaway point of the root loci on the real axis is dash. Actually, this is a famous question. Those students who attended my classes, either in the live classes or recorded lectures, you might be knowing that by taking this single transfer function, I have explained the root locus, RH criteria, gain margin, phase margin, Nyquist plot, polar plot, Bode plot, all these things I have explained only with single transfer function. Okay, then you will be able to know and how to connect all these things, right? Right. Yes, Ravi, you are right. But at least we are provided some calculator, na? Whether that is virtual or real calculator. I too agree that, but it is a little bit difficult with the virtual calculator. But calculator is given, right? You can do that calculations, right? So now, first of all, again get the characteristic equation. What is the characteristic equation here? 1 plus g of s into h of s, that must be equal to 0, right? So going ahead, you can write down this as 1 plus k divided by s into s plus 1 into s plus 2, of course, into 1, that must be equal to 0. So if you go ahead, you will be having like s into s plus 1 into s plus 2, right, plus k, that must be equal to 0. And from here, I can write down k is equal to minus of s into s plus 1 into s plus 2 here, correct? This is the way how you need to go for the breakaway point on the real axis. A, option A, very good. Many students have already done that. So k is equal to, what is this value? So we can say this as s square plus s, of course, into s plus 2 here, correct? So if you go ahead, then it is equal to minus of s cube, first of all, s cube plus s square plus 3s square, this one, and plus, of course, what else is there? This is going to be 2s here, correct? You will be having 2s. Now, how do we calculate the breakaway point? So breakaway point means where the sensitivity of the root locus come down to 0. Where the sensitivity of the root locus come down to 0. Of course, we are varying with respect to k. So the sensitivity of root locus will be nothing but dk by ds is equal to 0. Correct? So dk by ds is equal to 0. That means if you differentiate this, what you will going to get? When you differentiate this and equate it to 0, so it would be having like 3 times of s square. So differentiate this, then it will be 3s square plus, of course, 6s plus 2 equal to 0. Clear? Now take your calculator once again and put it in the equation mode and solve this. You will be having 2 roots for this. S1 is equal to minus 0.42 and S2 is equal to minus 1.58 here. Clear? Minus 1.58. Now the question is about breakaway point. Unfortunately, we have A, B, C, D. Many of the students, they will go for option C, that is wrong, right? So how do we check? Usually the breakaway point should come in between these 2 poles here. Clear? In between pole 1, minus 1 and minus 2. So the pole it should come, I'm extremely sorry here. So the breakaway point should come here in between these 2 poles, that is 0 and minus 1. So only option that is left here is A. Option A is the only point. Minus 0.42 will come in between these 2 here, correct? Otherwise, what is the best option here is, because I know that Sachin will ask the question now, right? So what I can say is, take this minus 0.42, right? Take this value of minus 0.42 and substitute in the characteristic equation. This is the characteristic equation. Clear? Substitute here. Then you will going to get k greater than 0. K, you will get some value for k and that is greater than 0. And again, you take this value of S2, right? And again, substitute in the characteristic equation. But when you substitute this point, you will understand that k is actually less than 0. Clear? K is less than 0. When you substitute this point, you will understand that k is greater than 0 in the characteristic equation, but this point will make k less than 0. What does it mean? As you all know that root locus is a plot that is constructed generally for the positive gain, right? Means k greater than or equal to 0. Correct? So that means this is the point which is validating with the fundamentals of the root locus. That means S1 is a point which is validating the fundamentals of the root locus. Therefore, I can go with the option A. Though when we solve this equation, we are getting 2 points. Out of these 2 points, only 1 point is there on the root locus. Other point will not be there on the root locus. That's why this is considered as a breakaway point. Clear? So, right. So that is the those are the questions which were asked, you know, on the root locus, and remaining questions are very easy compared to that. That's why I have taken these questions. Clear, sir? Very good. Right, Sai Charan. Thank you very much. Now let's go to the frequency response fatapat here. So the first question, I feel that this is the easiest question in the entire papers, including all papers of IIT Kanpur. This is the easiest question, right? 2001, that is 2 marks question. This is great people, that is right. 2001 they have given for 2 marks this, right? So the question is, the open loop DC gain of a unity feedback system with a closed loop transfer function is this, that is s plus 4 divided by s square plus 7s plus 13 is dash. Look at that, the open loop DC gain. Okay, so option A, 4 by 13. That's why, Jansi, you must be careful. Okay, I am saying this point, right? See, they are expecting the open loop gain of DC gain of the open loop system. But what was given to you? Closed loop transfer function is given to you. Correct? Closed loop transfer function is given to you, right? So from this, how do we write the closed loop transfer function? S plus 4 divided by s square plus 7s plus 13 here, right? So this must be written like g of s by s square plus, sorry, g of s divided by, right, g of s divided by, you have to make it like 1 plus g of s into h of s first. Clear? And it was mentioned that unity in feedback means h of s is equal to 1. So straight away I can take this h of s is equal to 1. Then you must be very careful with these things. That is s plus 4 divided by s square plus 7s plus 13 is equal to all the way this one, right? So now, yes, Babu Ranjan, to convert closed loop to subtract the numerator minus numerator from the denominator. Okay, right? Numerator from the denominator. That is one way you can actually do it very fast. I appreciate. Otherwise, you can calculate this and now get the value of g of s from here. This is also easy, right? So because when you multiply this 1 plus g of s into s plus 4, you must understand, Bablu Ranjan, this point that every student might not be equally talented. As a teacher, I need to cover all the students, right? So, but anyway, your answer is correct. I appreciate you, right? S plus 4 and right side what is there here? So s square plus 7s plus 13 here, right? So that must be multiplied by g of s. Clear? This is so simple. And now it's very easy. I feel that all of you can easily get from here g of s. So definitely g of s will come some value here. So some transfer function will come. So it's very easy. Just take s is equal to 0 in that, right? So if you substitute s, not s is equal to 0, basically you should substitute omega is equal to 0. Clear? Omega must be equal to 0. So when you substitute omega is equal to 0, naturally s will become 0, because the DC gain means when you operate with the low frequency or no frequency. Omega is equal to 0 means what? Basically that is a DC signal. So once you get the g of s here, substitute omega is equal to 0 and I am sure you will left with the option B. Clear? Option B would be the correct answer for this, but many of the students what they go for option A, which is wrong answer. But I appreciate a lot of the people have made this, right? Compare with the second order. Yes, that is also fine. Anyway, you can do in a number of ways, right? That is up to you, because this is an easy question only. Let's go to the next question. I think this question will take some time, at least 5 to 10 minutes. Guys, you must be with me. Okay. So this question was asked in the year of 2001 for 5 marks, right? So this will really check our patience now. It will at least take 5 to 10 minutes. Now take your pen and paper and work out with me. Don't leave the class in between. Be with me till the end. There are n number of questions about to come here. Today I will going to take the class up to 10:15 or 10:20. So please see here. Right? A unity feedback system has an open loop transfer function. G of s is equal to 1000. In fact, 10 power 4 divided by s into s plus 10 whole square here. Correct? Right? No. Ravi Shankar, in electrical paper in the year of 2001, okay, in the year of 2001, there were 2-tier exam. GATE was 2-tier exam. GATE was having a prelims and mains both. Okay, so that time in the mains paper they asked this question. Okay, 2001, right? So that is really crazy, right? GATE also has 2-tier in 2001, right? So unity feedback system has a open loop transfer function. This determine the phase margin and determine the gain margin, and is the system is stable or not, or unstable. So in fact all are given here, all are given. So if you answer this question, all the concepts of phase margin and gain margin and stability relation, everything will be cleared. Okay, so let's take up this question because this is good question actually, right? So whenever you are having this, it is better to write g of s into h of s like this first of all, which is equal to 10 power 4 because the numerator is 10 power 4 divided by s into s plus 10 whole square here. Clear? So what should I do? First thing, first get the magnitude and phase functions of this. Replace s is equal to j omega first. When you replace s is equal to j omega, g of j omega into h of j omega, obviously it will going to be equal to 10 power 4 divided by, when you replace s is equal to j omega, the denominator will become 0 plus j omega into, what it will become? It can be written as s plus 10 whole square can be written as, how can I write this one? This could be written as s plus 10 into s plus 10 here. So you can write down this as a 10 plus j omega into 10 plus j omega. Easy to understand, correct? So now if you go to the magnitude part, so how can I write the magnitude of this one? So the magnitude, which is considered as a modulus of g of j omega into h of j omega. See, please follow the steps here because ultimately we will land to the correct answer if you follow the steps properly. And the procedure what we are doing here, that is common for every gain margin and phase margin question. So please see this question, right? So this will be, if you take magnitude, numerator is a constant value, so it is 10 power 4. In the denominator, under root of x square plus y square, x square is 0 square, so no problem, y square all the way it will come like omega here, and this one and again this one. If you take the magnitude of both the complex numbers, it is same, so in fact it will become like, so 10 square plus omega square whole square. Clear? So therefore I can write down this easily as like this, right? So instead of writing all this and doing so much hangama here, what we can do is we can make like, you know, 10 square plus omega square here. Clear? This is considered as a magnitude. Wow, very good, Rajesh, 13.398, but wrong answer, please see here. But the phase, right? So the phase would be written as, how do we write the phase? So the phase is, there is a one complex number here in the denominator, 0 plus j omega, that is minus 90 degrees, and minus two complex numbers are there in the denominator of the same complex numbers. When it comes to numerator, it will become, you know, minus 2 tan inverse of imaginary part is omega, real part is 10. Clear? This is considered as a phase, right? This is considered as a phase and this is considered as a magnitude. Any answer from you guys? Because this is a good question. I know that it will take some time, but I want you people to do this because this is a good question actually, correct? So moving ahead, first of all, if you want to find out, okay, right, gain margin or the phase margin, if you want to calculate both, let us first start our game from omega GC. What do you mean by omega GC? Omega GC means the frequency at which the magnitude becomes 1. So modulus of g of j omega GC into h of j omega GC, it must be equal to 1. So what is that here? So this is a magnitude here. Therefore, what should I say? Can you repeat the phase of, phase of 10 plus j omega, right? So simple. See here we have 10 plus j omega here, 10 plus j omega, right? So whenever we have a complex number like s plus j into y, then the phase would be considered as tan inverse of imaginary part y, real part is x, y by x. Clear? Suppose if the complex number is like this in the denominator, clear, then its phase will become like minus of tan inverse of y by x, right? Suppose if you have x plus jy 2 times here, then the phases gets added. So therefore minus tan inverse of y by x, again minus tan inverse of y by x, so all the way it will become 2 times. Clear? That is the way how we got minus 2 into tan inverse of omega by 10. Is it clear? Now Ravi, please let me know, is it clear or not? Yes, Rajesh, correct. Ravi, please let me know, is it clear or not? Yes sir, thank you. Okay, fine, right? So omega GC must be equal to this. So what is this here? So right, so 10 power 4, how fast you are here? So Rajesh is too fast, right? So 10 power 4 divided by omega into 10 square plus omega square equal to 1, correct? So anyway, this is omega GC now. Now you must understand that, right? So here you will be having like omega cube, right? And then plus 100 omega, correct? So 100 omega and minus 10 power 4, this would be equal to 0, correct? So this can be written as a characteristic equation like omega cube plus 0 into omega square and plus 100 into omega minus 10 power 4, that must be equal to 0. Can anybody say if you solve this what would be the value? No Madhuri, you are wrong again. Again there is a calculation mistake from your side, so please be very fast. Now if you take the calculator and do it, I am sure you will going to get omega GC here as equal to any one of you. You will be getting 20 radian per second. It's not difficult actually, it's easy only. Just substitute 20 here, then you will understand. So 20 if you substitute, what will going to happen? 20 whole square you will be getting. Otherwise substitute 20 here, even in this equation you will understand omega GC is equal to 20. Clear? Omega GC is equal to 20. Now the next one is omega PC, right? So we must calculate omega PC. How do we calculate omega PC? Omega PC is the frequency where the phase is equal to minus 180 degrees. How do we do that? Phase is going to be this all the way. This is easy, right? So phase is all the way this one, right? Now if I put it here, so the phase must be equal to minus 180 degrees. So that is minus 90 degrees minus 2 tan inverse of omega by what would be the value? Omega by 10, right? So let me write down omega by 10 equal to minus 180 degrees, correct? So moving ahead with this, right? So minus 90 if you take to that side, minus 90 it will become, so minus 2 tan inverse of omega by 10, this would be equal to how much? Yes, so minus right, so it will be minus 90 here, and then I am very sure that then it will become like tan inverse of, look at that, this is very fast. So tan inverse of omega by 10, of course it will be minus 90 divided by minus 2, it will be 45 degrees here. Therefore if you go ahead, so you will be having omega by 10 is equal to tan of 45 degrees here. So tan 45 is equal to 1 here. So therefore what should I say here? Omega is equal to 10 radian per second. Of course you must say omega PC, this is clear. Why omega PC? That is what we are calculating, right? So by looking at this you must understand one fact here, because those students who attended my classes already, it is cakewalk to them. They might already got the answers, right? So omega PC is equal to 10 radian per second and omega GC is equal to 20 radian per second. It's clearly showing that omega PC is actually less than omega GC here, correct? So omega PC is less than omega GC, means the system is going to be unstable. Closed loop system will be unstable. If the closed loop system is unstable, then gain margin and phase margin both will come negative. Let us see how it is. Clear? So let's move ahead, right? So how do we calculate the gain margin now? Fatapat. Gain margin, as I was saying, it is equal to Kg. Usually we write like this. Kg is equal to 1 divided by modulus of G of j omega Pc into H of j omega Pc. Clear? So 1 divided by this. This is the gain margin. Of course, the logic was clearly explained in the regular classes, right? Yes, right? Omega GC does not satisfy the equation. No, it will satisfy. If you want, you can see here. So 20 cube you can keep here, right? And you multiply 20 with this. So it will become 2000 and it will become 8000, correct? 8000 plus 2000, that is 10,000 and minus 10,000. So correct, it will satisfy. You might have done mistake, so please see, right? So Kg can be written now as 1 divided by modulus of this one, right? So this is actually considered as your magnitude, right? So let me go ahead and make it. So 10 power 4 will be there here, divided by omega Pc, right? And then 10 square plus omega Pc square here. Clear? And I'm very sure if you make it so clearly and properly, omega Pc, how much we got? Omega Pc we got like 10 here, right? So it will be 10 into 10 square plus 10. So what is that value? 100 plus 10 square, right? So it would be 2 times of 10 square if I am not wrong, correct? Right, divided by, of course we are having 10 power 4 here, correct? So what is this value? This is going to be 2 by 10, which is actually nothing but 1 by 5, clear? So Kg is equal to 1 by 5. Gain margin Kg is equal to 1 by 5. But they are asking in terms of dB, right? So in dB if you want, gain margin in dB would be written as 20 log of Kg, right? So 20 log of Kg, what is the value here? So 20 logarithmic of 1 by 5. Fatafat, can you do anyone? So 20 log of 1 by 5. Yes, already somebody has given here, right? So 1 divided by 5. So this is equal to minus 13.98 degrees, minus 13.98 degrees. So sorry, minus 13.98 dB. I'm extremely sorry. Right, minus 13.98 dB. This is what I was saying. In fact, the gain margin is negative. Correct? Gain margin is negative. From there itself we can say that it is going to be unstable. Correct? So gain margin is negative. See, whenever omega PC is less than omega GC, it is a natural expectation that the gain margin and phase margin both will come negative. Let us look at what is the phase margin now. Phase margin is going to be, if you want phase margin, you should find the phi GC first of all. Phase at gain crossover frequency. What is the phase here? So look at that. The phase expression is this. Correct? So moving ahead, minus 90, minus 90 degrees, minus tan inverse of, what is the value of the phase here? Right, omega by 10, right? Minus 2 times of tan inverse of omega GC divided by 10. Correct? So going ahead, what is this value? Minus 90 degrees minus 2 times of tan inverse of omega GC is 40 divided by 10 here. Correct? Sorry, 20 divided by 10. I'm extremely sorry. This is going to be 20 divided by 10. Yes, give me 1 second time. Right. So 20 divided by 10 here. Right. So this is going to be minus 90 degrees minus 2 tan inverse of 2 here. Right. So what is this one now? Right. So I would say, right, somebody has given already the answer, but good. So tan inverse of 2, right. So it will have some value into 2 and plus again 90 here, right. So it is 216.86 degree, right. So minus 216.86 degree. Do you think that this is a phase margin? Because some students have told that this is a phase margin. Rajesh, wrong, right. You are the person who is giving the answer so fast. But this is only minus 216.86. This is not the phase margin. Now you should calculate the phase margin. How do we calculate the phase margin? Phase margin is equal to 180 degrees plus phi GC. What happened to Jansi and other students, Jansi and Madhuri? Quick, fast. Okay. Bablu, you also answered wrongly. I didn't expect, right? 180 degrees plus phi GC, right? So what is the value here? 180 degrees plus phi GC means minus 216 plus 86 degrees. So obviously you will going to get how much here? So the phase margin is, if I am not wrong, minus 36.86 degree. Clear? So the phase margin is also negative here. Correct? Phase margin is also negative, that is minus 36.86 degree. That means you already crossed the border of minus 180 degrees. So what you need to do? You should actually come back. That means you need to use the lead compensator. Lead compensator must be used to add the positive phase to this number, so that the net phase will be less than minus 180 degrees, like minus 160, minus 140, like that. Clear? So the idea is, here phase margin is negative and the gain margin is negative. Obviously, what would be the correct answer here now? Right? System is stable or unstable? System is, closed loop system is unstable. Clear? So the concepts of gain margin and phase margins are really useful for us to evaluate the closed loop system stability. Clear? So guys, I may take another 10-15 minutes, right? So we'll go ahead, right? So frequency response plot, please don't mind, just 10 minutes, okay? Right. So because these questions I don't want to miss, because these are very, very good questions actually. Frequency response plot. This question was asked in the year of 2015 for 1 mark, okay? Formula gone. Right. Rajesh, that's why I'm saying clearly every time, more than formula, you need to keep your mind attentive. Okay, minus 216 you got. What does it mean? Phase margin means anything if you go beyond minus 180 degrees, you will be struggling, right? You should be always less than that minus 180 border. So you crossed means phase margin will going to be negative. This is the way you should think, right? Don't use the formulas more and more. Okay, right? Now this, see, formula is required, at the same time you require the concept also. That is what I mean to say. So electrical set 3, that is ECE set 3 2015 for 1 mark. This is a good question. Let me see how many of you will answer this, right? So consider the Bode plot shown in the figure. Assume that all the poles and zeros are real valued. This is good question. Good, very good. Real valued means they are real numbers. The value of FH minus FL in Hg is going to be dash. So look at that. This is the frequency plot. So easily they have given, right? IIT Kanpur people are little bit intelligent. So they made like this is a 300, correct? But if you look at, this is a lower cutoff frequency and they have mentioned that 40 dB, right? They didn't mention properly here, but it is a plus 40 dB per decade. Clear? So let me write down this as a decade, 40 dB per decade. What does it mean? So when we, and you see, when the frequency is FL, the gain is 0 dB, and when the frequency is 300, gain is 40 dB. Correct? So that means from here to here, what was the gain increment here? So it is 40 dB, because 0 dB became like 40 dB means 0 dB became like 40 dB means 40 dB is the gain. Correct? 40 dB is the increment here. So but what it is saying, 40 dB will increase for 1 decade change. Clear? Means from here to here, the frequency is actually raised by 1 decade. That is the reason why the magnitude changed from 0 to 40 dB. So then what does it mean? FL should be, or 10 times of FL, 1 decade means 10 times of FL must be equal to 300. So FL is equal to 300 by 10, that is equal to 30 Hz. Clear? Good question. Correct? Lovely question, right? So that means there, yeah, no, one is pole and another one is 0. Please look at carefully, Jansi. Okay? So here at FL, the slope is increasing, means there is a possibility of having 0 there. 40 dB plus decade means when you raise the frequency for 10 times, the magnitude will rise by 40 dB. So after rising 10 times, you are having the frequency 300. Then what should be there here? 30. Then only 30 into 10, it will become 300. Simple logic, correct? So it is going to be FL is equal to 30 Hz. Now at the same time, you see here, from this there is a pole. That's why it is going like minus 40 dB per decade here. Clear? Minus 40 dB per decade. And again at 900 Hz, we have 40 dB here, and FH we have 0 dB here. That means 40 dB is a loss here. 40 dB is a loss means, according to the slope, 40 dB is a loss means 1 decade change should be there in the frequency. That means if it is 900, it must be 9000. Correct? Then only 1 decade change will be there. Correct? So good question, isn't it? So 900 to 9000, it is 1 decade change, and from 40 dB to 0 dB means it is 40 dB is a loss. Then the slope is matching like minus 40 dB per decade. So it is 9000. So ultimately we got like FH is equal to, give me 1 second, right? FH is equal to, how much we got here? FH is equal to 9000 Hz, right? And FL is equal to, what is the value here? 300 Hz here. So then what is the bandwidth now? Now bandwidth could be written as, look at that, bandwidth is always FH minus FL here. So FH we have seen that 9000 minus 300, of course this would be in Hz. So what would be the value finally? This is going to be 8970 Hz. And I think probably, oh, now everybody has done. Very good, right? Excellent. So tell me, is it good question or not? I love this kind of questions. See, this question, relatively it is not requiring, so much of, hard work, paperwork. It requires logical mind. And most of the times the GATE questions are like this. That's why I told you even in the yesterday session that GATE questions are aptitude in technical. Okay. So now see, this is the way you should think. If you start applying the formula, it's difficult. So 1 decade change, 40 dB is the gain increase. So that means after 1 decade, 300 should be here. So that means here you must have 30. That is the way you should think. Is it good question or not? First of all, you have to comment here. Otherwise, I will be disappointed. So please tell me, is it good question or not? Anyway, that question I haven't prepared. It was prepared by IIT Kanpur. Correct? Yes. Good. Now the next is electrical. 2015. One more question. First, anyone? Any one of you? Right? So a Bode magnitude plot for the transfer function g of s of a plant shown in the figure. Which one of the following transfer function is the best for this plant? Yes, sir. It's great. See. Those who attended my session on Bode plot, I have told both the ways, how to solve the question from the basics and then how to answer by looking at the question. Now drop your pen and apply your common sense. Common sense, okay, common sense. Common sense is most powerful weapon compared to physics, mathematics, chemistry and all the things, okay. Apply common sense, right? So what common sense says? See, this is a Bode plot, of course, right? One interesting thing is, it is following the constant slope here like this. If it is constantly following a slope, it might be having some gain, k, right? So I can write down first of all g of s is equal to some k. I don't know what is the value of k, but let me keep that as a k. Clear? And you can see here exactly at this value. At this value, I must say that it is reducing its slope, right? It is reducing its slope. Now have you seen here exactly at 10, it is earlier at 20. Now you can see maybe it is actually falling like this, and you can see clearly that, right, exactly at 1000, 1k means 1000, it is falling up to minus 20 here. Clear? So can you tell me what is the slope of this line? What is the slope of this line? Any one of you, fast. What is the slope of this line? The slope is from 20 it came to minus 20. From 20 rupees you came to minus 20 rupees. What is the loss? From 20 rupees you came to minus 20 rupees means what is the loss? 40 rupees is the loss. Correct? From 20 rupees you came to minus 20 means 40 rupees is the loss. Correct? So that means for 20, if you add minus 40, then only you will going to get minus 20, isn't it? So that means adding minus 40 means it is a loss of 40, right? So therefore this must be written as minus 40 dB, but how many decades here? Look at that. At 10, correct, you are having 20, and at 1k means it is from 10 to 100 1 decade, and from 100 to 1k it is 2 decades, right? Means so from here to here it is all the way, it is about 2 decades here, correct? So therefore I can say minus 40 dB divided by 2 decades, right? 2 decades, all the way what it will going to become? Minus 40 dB per 2 decades means quite logically it is going to be minus 20 dB per decade, correct? So it is very easy because we are working only with the LTI systems, correct? Minus 40 dB per decade here, sorry, minus 20 dB per decade. What does it mean? There is a possibility of having a pole of order 1, correct? Pole of order 1, direct verification. Yes, Rajesh, direct verification is the easiest one, okay? I will tell you that also, right? K divided by S plus 10 we are going to have, clear, of order 1, clear, S plus 10 of order 1. Now look at that, which option is going to have this one? Unfortunately, it is not the correct answer, correct? Because of course, here at 1k, you can see, again the slope become like 0 dB per decade. What does it mean? 0 dB per decade, it become like means from minus 20 dB per decade, it becomes 0 dB per decade means what? Slope is increased by 20 dB per decade. Minus 20 dB per decade became 0 dB per decade means slope is increased by 20 dB per decade at 1k. So that means it will be like S plus 1000. It is a 0. This is the pole of order 1 and this is the 0 of order 1. So which one will going to satisfy this answer? Obviously you have only one option, there it is goes like D, correct? D is the only option that is going to satisfy, right? That's exactly that. And another way is, look at 10 the slope is decreasing, that means there is a pole. At 1k slope is increasing, means from minus 20 dB it becomes 0 means slope changes 20 dB per decade, correct? So this is 0, this is pole. That is only possible with the option D. You don't require to take this much of time also. Very good. Thank you, Mansvi. Right. I'm great to see that almost everybody is there still with the great patience in the live box, chat box. Very great commitment, guys. I really appreciate. Now look at this and don't put your pen on the paper. Now let's do like Rajesh, because Rajesh is doing magnificent. So let us see and evaluate like Rajesh now. Right. Don't put your pen on paper. I'll show it to you how to do just by looking at the options here. The asymptotic approximate blood of so much is given here, and anyway they are having some plot and they want to get what is the transfer function of this. Look at that. So first of all, always try to understand like this. Go to the options first. In the options you can see poles and zeros combination is different, correct? So that means first of all identify what is the pole and zero. So 0.1 it is actually coming like this at the slope, right? So it's coming down. If it is coming down with the initial slope of minus 40 dB means g of s will going to have some k will be there. Generally in the denominator we will be having s square, because minus 40 dB per decay from the starting at 0.1 means it is having the initial slope that is going to be with the poles at origin, right? S square, because minus 40 dB per decay flat. So obviously we can eliminate A and B. Finished. Fatafat. Right? So C and D you should check it. What is the best way to check C and D? The best way to check C and D is, let us select one of these options. Clear? So look at only one of these options you select, right? A and this will be wrong answer, right? Now you can select either C or D. If C is correct, then D need not to check. If C is wrong answer, then we can go for the D blindly there. So how do we do that, right? So simple. If you select C, first select C. No, many of you, right? Rajesh, C or D, correct. Ritik, Pramit, Rajesh, you check it clearly, right? So when you take C here, G of S is equal to C. If you take 20 into S plus 5 divided by S square plus S plus 2 whole into S plus 25, correct? Now if you substitute j omega and magnitude of j omega, all this blah blah blah, what it will going to become? Modulus of j omega. I am directly writing here. So let us see what it is going to be. 20 into under root of 25 plus omega square, correct? In the denominator, what you will going to have? So in the denominator, this is going to be omega square, and here under root of 4 plus omega square, correct? Under root of, so 25 square, so 25 square plus omega square, clear? Now after making this one, so what we should do? Substitute omega is equal to 0.1. Don't substitute high frequencies. Don't substitute high frequencies, because at higher frequencies there is an error between the exact Bode plot and approximate Bode plot. Always you should substitute the lowest frequency that is available in the plot, where you will find the greatest accuracy. Remember this point. At lowest frequency you will be having the greatest accuracy. I repeat, at lowest frequency you will be having the greatest accuracy. What does it mean? Substitute omega is equal to 0.1. Omega is equal to 0.1. Now Rajesh and Pramit, you both check for option D. You both check for option D. Now I will do it for option C. You both guys, you do it for option B, option D, right? Modulus of j omega. So if you make it this, what you will going to get? So when you substitute omega is equal to 0.1, obviously I can neglect this. So if you substitute 0.1 here, 0.1 square is 2 less compared to 25. So under root of 25, it will be just only 5 here, clear? Divided by, here what it will be? 0.01 into, what you are going to have here? 0.1 when you substitute it here, 0.1 square, 2 less compared to omega. Yes, Hritik, correct. Hritik, correct. And Pramit and Rajesh, you both have done mistake because of fast, and your accuracy is very important, okay? These kind of questions, if you do a small mistake, which are the easiest questions here, you will regret a lot after finishing the GATE examination. Instead of going to IIT, you will go to NIT. Trust me, that will happen. So you should be very careful, right? So 0.01, and here you will be having 4, and what is this value here? Again 25 will be there here, correct? So now I must say this one as here 5 times here, and 5 into 5, 25 will be out now, right? So then 1 by 0.1, and you will be having 100 here, correct? And 20 log of this modulus of j omega, if you calculate, because we need to calculate in dB, 20 log of 100, it will be 40 dB here, clear? 40 dB. That means option C is saying that the DC gain is 40 dB, or the gain when you substitute omega is equal to 0.1 radian per second, approximated I have taken. I agree that I have taken approximate, but it is showing 40 dB at 0.1. At 0.1 it is showing 40 dB, correct? So option C is the wrong answer. Option C is the wrong answer means, then definitely option D is the correct answer, clear? Option D is the correct answer. That's why again and again I am saying and sincerely requesting every one of you, you must not be overconfident. Accuracy plays very important. How much patience you are having while you are solving the questions, that much accurate you will be able to do, clear? So the correct answer is going to be option D. Agree with me? So please check other people, right? Option D is correct or not? Check it, every one of you. Only Hritik got it. What about Rajesh, Pramit, Manasvi Agarwal, and every one of you? Option D or option C? Option D is the correct answer according to me, because I know that, right? Okay, next ECE 21, that is for 1 mark. This is simple question. I feel you guys can do. The Nyquist plot for the open loop transfer function g of s of a unity negative feedback system is shown in the figure. G of s has no pole in the right hand side of S plane. What does it mean? G of s means open loop system, clear? G of s. Guys, what happened to the previous question? D or C? Have you got that D or not? I eliminated option A and B and C, then fixed that D as the correct answer. Yes, got it. Very good, Rajesh, right? So G of s has no pole in the right half of S plane. the number of roots of the system of characteristic equation in the right half of S plane is dash. Clear? G of S has no pole in the right half of S plane, and G of S is a open loop system, correct? What does it mean? No pole in the right side of the S plane means I should say this is open loop system is stable. Open loop system is stable means there are no poles of open loop system that lies in the right side of the S plane. Clear? Now look at the Nyquist plot. So how do we evaluate the closed loop system stability from the Nyquist plot? Simple. We must find out the number of encirclements, right? So how do we find the number of encirclements? About -1, 0 point. So here -1, 0 point. This is just very easy. Draw a line like this. Simple. Draw a line like this, right? When you draw this line, so is it looking something like this? From -1.0, -1, 0 is a point. When you draw like this, have you identified this point here? Look at that. This is actually cutting like this, right? So this is the direction. So that means there is one cut in this direction. I repeat, there is one cut in this direction, and this one here, it is actually going in this way. So that means this is going in this way. Clear? So what does it mean here? This is clearly showing that one clockwise encirclement, and this is showing that one anti-clockwise encirclement, correct? So all put together, how many anti-clockwise encirclements are there here? So n is equal to one clockwise, one anti-clockwise, means total it is going to be 0. So the number of anti-clockwise encirclements about the point -1, 0, total number of anti-clockwise encirclement equal to 0, correct? But generally according to the Nyquist criteria, we must equate these to P minus Z. Clear? And if anybody has a doubt in this concept, please go to my recorded lectures. You will be able to find out Nyquist stability criteria. I have taken so many lectures and explained so clearly in the recorded lectures. Not only the stability criteria, just like formula, I have explained the background of this also. What is the meaning of mapping, how mapping is done, everything I have done it, right? N is equal to 0, which is equal to P minus Z. You can find the recorded lectures in the BEP app. Somebody is asking here to me personally in the WhatsApp, so that is the answer, right? So N is equal to P minus Z. So here you must understand N is equal to 0. This means that P is equal to Z, okay? Now you must understand what is P and what is Z here. P is actually nothing but number of poles of the open loop system that lie in the right side of the S plane. How many poles are there? See, open loop system is stable. Means what does it mean? Number of poles of open loop system lies in the right side of S plane equal to 0. Clear? Because if it is stable, there is no pole of open loop system that lies in the right side of S plane, correct? So P is equal to 0. So P is equal to 0 means I can say this is equal to 0, and eventually Z will going to be equal to 0. So if Z is equal to 0, what can I say? Z is equal to 0 means the roots of the characteristic equation are the poles of the closed loop system. See, Z is actually representing poles of the closed loop system lies in the right side of S plane. How many are there? 0. That means there are no poles of the closed loop system that lies in the right side of S plane. So the answer is going to be how much? Option A. Clear? Option A is the correct answer, and this was asked for 1 mark. So with this, I have completed the questions on root locus and frequency response, and then frequency response plot. Hope you really enjoyed this lecture. So already we are running out of the time. I have taken 1.5 hour session, and I am really seeing the great attention by you guys. Almost the number is constant. Okay, excellent participation. I hope you really enjoyed with the lecture. Have you really enjoyed? So please message in the chat box. And anyway, I too agree. We left with the small portions like compensators and controllers, followed to that state space analysis, right? So what we do is, I will take one more session if possible. Otherwise, you can find some of the questions related to compensator and controller, especially in the GATE papers, IIT Kanpur. These are not so difficult question. I feel that you can do it. However, I will going to take one more session if possible, only on this state space as well as compensators and controllers question, right? So definitely we will going to discuss once again if time permits. But however, I request you to solve this question, because state space, those students who attended my lectures, they people knows very well that I explain the state space so easy way. You don't require to remember so many formulas like B into SI minus A whole inverse into C or else all these things. Just one common bottom line you need to know, basic line, and if you integrate that, you will going to get the answer for anything. That's why I am saying that those who want to know about the control system lectures, go to BEP app and download the recorded lectures. In fact, in the recorded lectures of control system, you can find my lectures. There you can find how I have taken a single transfer function and explained the whole control system, and connection between the root locus and gain margin and phase margin, and connection between the root locus and stability, and then frequency response plots. All are interconnected and you will really love it. Okay, so fine. Yes, please take one more session. Definitely, Ritik, as you all people are asking, definitely I will going to take, and we require to cover a small portion, that is compensator controllers and state space analysis. But I really loved your sessions. Okay, I really loved the interaction with you guys and hope these sessions are really useful to you. As I promised, we will try to take one more session on these topics. Otherwise, you just practice these questions, and if you have any doubts, you can post me directly to my number. That is, you can take my number 8144829925. Clear? This is my number. You can directly ask the doubts to me. And if you want my control system lectures, you can directly download the BEP app. And if you are already the paid member of us, no problem. Then you can use the app. There, go to the recorded lectures. There you can find my control system lectures. Clear? So hope this session is really useful for every one of you. In fact, I enjoyed a lot and I have taught everything so sincerely. So if you have any doubts, please message to this number. I am always available and answer to your questions. And you are requested to answer the solutions in the comment box once the live session is completed. Tomorrow or day after tomorrow, I will come and answer in the comment section to every one of you. Hope you really enjoyed it, right? Pani sir, yes, okay, great. So my name is Phanindra. So you can see this and enjoy the lectures of control system on BEP app. Once again, thanks to everyone who is participating sincerely in the session. Hope I wish all the best to everyone. Thank you once again.